Hi guys, sorry I'm not with you today. So what I'm going to do is show you the detailed answer key um, for the 1998 multiple choice. So I will click through the different screens. So I would recommend that you pause the video so that you could read through the detailed answers as I go. So here's questions 1 through 6, and now I will switch to the next questions. Okay, here are questions 7 through 11. So if you want to read in more detail for 7 through 11, you could pause now. Here are the detailed answers for 12 through 19. Again, if you want to read through any of these, you can pause the video now. Here is questions 20 to 23. And you can pause. Here's 24 through 28. And the next questions are the calculator questions, so there might not be as much work to show. So here we go. 76 to 83. 84 to 87. Again, and pause if you need to. 88, oops, excuse me. 88 to 89. And finally 90 to 92. Again, some of these might not make sense because you did not have the true answer key. Or sorry, you didn't have your calculator. Okay. A couple of you said you wanted to talk about question 2. So I guess what you can do though is you can make this a triangle. We have a rectangle here and a triangle here, or the area of a trapezoid. And then remember the areas from 2 to 4 are below the x-axis, so they're negative. So this first part here is a negative half, and this part here is a negative 1, so it's negative 1.5. Okay. Looking at questions, let me zoom out a little bit. All right, go back. If we look at questions, question 4, some students asked about continuous and differentiable. Basically, answer choice A is the mean value theorem, and this question is the setup for the mean value theorem. Looking at question 6, you have to do implicit differentiation. So the derivative of x squared is 2x. xy requires product rule, so the derivative of x is 1, then times y, plus x times the derivative of y, which is dy dx. So it looks like if you plug in 2 for x, we would have to plug in another value for y, and you could do that by plugging in 2 into the original equation and getting y. So when you plug in 2 here, you get 4, and you subtract, you get 6. So when you plug in 2 here, 2 times 3 is 6, so the y value is 6. So 2 times 2 here is 4, plus 3 is 7, and then this is 2 dy dx. So if you subtract 7 and divide by 2, dy dx is negative 7 over 2. Okay, so that's question 6. There were some questions on 7. What you need to do with 7 is to, is to divide each term by x. So x squared over x is x, and then this will be minus 1 over x. So it'll be x minus 1 over x. So the integral of x is x squared over 2, and then the integral of negative 1 over x is ln of x. Okay, so you should have x squared over 2 minus ln of x, and then plug in your e and your negative 1. Sorry, e and 1. Okay. Question 8, there was a question on let f and g be differentiable. Okay, they're saying that g will always be positive and that f of 0 equals 1. So this looks like product rule. And so they're saying that when you do product rule, the derivative, which should be f prime times g of x equals f of x times g prime of x, then what does f of x equal? Okay. If you take the product rule of f of x, g of x, you end up with this. Because h prime of x is only equal to this according to the question, that must mean this part must be 0. For this to be 0, they are saying that g of x is always positive. So for this to be 0, that would mean f prime has to be 0. So if the derivative is equal to 0, that means the original function is a constant. So for this to be a constant, they're telling you here that f of x must actually equal 1. It is always equal to 1. Therefore, the answer is E. Let's keep looking. Question on 9. Okay. Okay, so this is a graph of barrels per hour. If you want to find out the total number of barrels, you'd have to take the integral, which means the area under the curve. So it's also asking about an approximate value. So if you look, how many squares are underneath, or I should say rectangles are underneath this curve. So here I count 1, 2, 3, 4, and then both of these look like they're a half, so it's about 5 rectangles. But each one is not worth 100. Each one has an area of 600 because it's 100 by 6. So 5 times 600 gives you 3,000. Okay? So the next question is 10. What is the instantaneous rate of change of this function? So you'll have to do quotient rule and then plug in the number 2. So quotient rule and then number 2. Instantaneous rate of change would mean f prime of 2. Okay. All right, question 12. Sorry. Okay. I've given this question to you before on a test or quiz. Basically, whenever you're given a limit question, you take the number and plug it in. So if I were to plug in 2, I'd get the ln of 2 here, and if I plug in 2 here, you'd have 2 squared ln of 2. So that would be 4 ln of 2 compared to ln of 2. Because those are different y values, this would not kind of be a continuous function. So the limit does not exist. The left-hand limit is ln of 2, and the right-hand limit is 4 ln of 2. They don't match, therefore the limit is non-existent. Okay? Question 13. So for question 13, the answer is 0 and 2 only. it is clear that it is not differentiable here at 0 because there's this break in the graph, but it's also not differentiable here at 2, and they're explaining here because there is a vertical tangent. Vertical lines have slopes of, basically there's a rise but no run, so it would have, let's say, a rise of 3 but the run would be 0, so it's like dividing by 0, which is no good. So B is the correct answer. Okay, question 15 is next. Again, so you're given big F of x is this function here. We just need to find f prime of 2. So literally, you are taking the derivative of an integral, which means we're going to take, all we have to do is take this x here and plug it in for t. So our function now is the square root of x cubed plus 1. So now we just have to plug in 2 there. So 2 cubed is 8 plus 1 is 9, and the square root would be 3. So the answer should be 3. Okay, I actually love question 17. They're saying that this is the graph of f, and we're comparing what's happening at x equals 1. So what's easy about this is that f of 1 is clearly on the graph, and the value of that is 0. But then we're now comparing the slope at 1 and the concavity at 1. Okay, so the first derivative deals with the slope of the tangent line. So all the slopes here at 1 should be positive. So it's a positive number. And this is curved downwards, so the concavity is down, which means the second derivative is negative. So with this symbol, it means less than. So what's the smallest would be f double prime. And then you have the number 0. And then we have positive numbers. So it looks like it's answer choice D. Okay, looking at 19, the points of inflection, you are considering the second derivative, which is here. And the critical values are 0, -1, and +2. Usually it is a sign that because of the square, okay, on this factor, the 2 here, that it's likely not going to change signs when you make a number line. So you should make a number line with the numbers -1, 0, and 2, and it will not change signs when x is equal to 2. Okay, so it's just C, -1 and 0 only. Okay. All right, question 20. What are all the values of k? Again, you just take the integral of k squared, x squared, which is x cubed over 3. You're going to plug in k, and then you'll plug in -3 and subtract. Again, I would look at the work at the beginning of the video for a little bit more detail. Okay, so it's only answer choice A. All right, 21. All right, this is popular. It shows up again, I believe, in question 84. You have to do separation of the variables. So you'd have dy, okay, and put the y underneath, okay, equals, keep the k where it is, and then you'd have dt, okay. You're going to integrate both sides, and then the left side should be the ln of y, okay, ln of y equals, it's going to be k dt. sorry, kt, sorry, plus c. Okay, I have to stop here.